All right, welcome to commenting. So we're going to do just a short video on commenting code and what's going to be expected of you in coursework. And this is also what's expected of you in the professional world. So I try to keep things as close as possible to what you're going to expect professionally. There are some deviations to that. My comment is going to be a little more explicit, a little more verbose than what you're going to do in the professional world. But that's for a reason. It's for training purposes, right? We're trying to get you to think about what you should comment, what you may not want to comment later when you're doing things professionally. And it's also designed to make you think about what you're learning. So the commenting guidelines here are a little bigger than probably what you would expect professionally, but not much. And they follow the same format. Okay, and I'll explain the difference between the academic parts and the professional parts as we go. All right, so I already got into the purpose a bit, right? The commenting standard is designed to develop professional documenting habits and consistent coding discipline. So one of the things that I believe in when you're teaching somebody programming is to develop the professional habits. The sooner you develop them, the sooner you can stop thinking about them, right? Once they become habit, once they become just ingrained into your daily processes, you don't think about it anymore, and you can spend more time thinking about code, which is what we want to think about. These standards also support the AI integrated classroom, and that is where I have used AI on purpose, purposefully to generate code. But you need to write comments to explain the code, right? So hopefully that's helping you understand the code that you're writing by thinking about it afterwards and then writing comments. Now, technically, you could actually have the AI also write the comments. And then you could just ignore that and not read the comments, but then you wouldn't be learning anything, right? So even if you have AI generate the comments for you, that's fine, but read them, understand what is going on in the code that you're commenting. All right. So as I already said, some required fields and some empty sections you're going to see are intentionally more explicit than typical production documentation. I'm doing that on purpose because I want you to think about parameters that you're not using just as much as you're thinking about parameters you are using. I want you to think about exceptions that don't happen as much as you are thinking about ones that do happen, right? Because we're in the learning process. But in general, what you're going to see here for the examples are pretty close to what you can expect in the professional world, and that's what we want to get you used to. So the process is you'll check the complete examples. We'll click on that in a minute and check it out. I provide them for both Python and C++ because that's mostly what I teach. If I teach something else, I'll get into that. And you have to follow them exactly. So I want to stress this part. Exactly, right? We are in an academic environment, and part of what you do in an academic environment is you teach discipline, okay? And that's what this is. This is about programming discipline, coding discipline, computer science discipline. And one of the most important things in that field is exactness. In fact, it's probably the most important thing, right? Programming is an exact discipline. You have to do things perfectly. You forget a semicolon, you forget an equal sign, you forget a space where it's supposed to be, you forget a tab, the whole thing doesn't work. I don't care if you have a million lines of good code. If one of those lines is missing one character that it should have, the whole thing doesn't work. Okay, so we teach exactness. So we're going to do that. I'm going to follow that concept here with doing the example, following the examples exactly. Okay. So the C++ examples follow the DoxyGen style of documentation block, so it's a professional standard. I'm not going to go through all these right now. Let's just jump over to the examples, and it'll be obvious, but just from the examples. The Python examples use standard Python doc strings, and they follow the current standards, okay, the current official Python standards, okay. But again, a little more verbose, but you'll see that. All right, so let's look at the examples. So you'll click on the examples, it'll take you to a repository, of course, because we work in repositories and we do everything as close to professional as possible. So the C++ folder is here, the Python folder is here. C++, like I said, it follows the DocGen standards. The Python follows the PEP8 standards. Okay, so we'll take a look inside. Now, what I've tried to do is I've given you an example of each kind of file that you're likely to work with in coursework, and the most common files you're going to work with professionally as well. So we're going to take a look at each one very quickly. I'm just going to highlight it, okay, so that you just understand the highlights, but then you have to come back and look at it closely. You should also read this README file very carefully, right? It tells you everything about what a proper README file looks like, okay? So you're looking at a proper README file that is explaining the repository, but it's also explaining why we're doing this academically. Okay, so you should read that yourself to make sure that you understand it. And a lot of things, a lot of questions you have will be answered if you just go through and read this README file. So this README file is, again, two purposes. It's showing you what a good README file looks like, because you also have to do that in coursework, but it's also explaining why we're doing this commenting the way we're doing it, okay, what the purpose of it is. All right, so let's look at some things, right? So let's start with main.h header file. So commenting here is very simple. It's just a comment block at the top. And I'll stress this, every single code file has a comment block at the top. That's normal in the professional world. It's normal in my courses. It's required. You must have it to get credit for your assignment. So every file has a comment block, every code file, okay, at the top. So this is a file comment block, and it has your name, has the assignment, has the purpose. Now, in the professional world, this is going to be even bigger. So this is an example of where I'm doing less detail than professionally. Professionally, this is much bigger. It's going to include a date. It's going to include probably the authors. There's multiple authors. It's going to include the last person that touched it. Maybe it has the last modification that was made, something like that. So this is usually a lot bigger professionally. But here, you just fill in these three fields. Tailored to each thing you do. The assignment will always be different. The purpose will be different, and that's it. Okay, that's all that you need for a header file. You can put in single line comments like this if you need them for your own purpose. That's okay, but this is what is required. The comment block at the top. Okay, so let's look at a code file. So here's main. So again, main has a comment block at the top, right? Every file has that. I'm going to stress that. Main also has a function comment. Okay, so every function has a function comment. All right, so you put it right above the function name in this exact style. Now, this is not a style I made up. So as I said, this is the DoxyGen specification, and it's used to create documentation from code. So that's really important. You need to understand that. We have, even though it doesn't affect the code, like these comments have nothing to do with the way the code runs, has nothing to do with compilation, doesn't matter, okay? It's just the way we do it. Okay, so this is the way that it's done so that you can auto-generate documentation. And so in each case, okay, you'll see here that it has a parameter, an exception, a return, and a note. Okay, now in the professional world, if these were all none, would you include them? Probably not. I mean, there may be some standards where you do, like some companies may say, yeah, do it, but you probably would just not have anything here. If it's none and it doesn't apply to anything, maybe the only thing here really would be the exit code, because there is an exit code. You might have that statement, but you wouldn't have these because they say none. But you have to have them for class. Okay, the purpose of that is I want you to think about it. I want you to be aware, because you're still in the learning phase. I want you to be aware that there are no parameters here. We can see that in the header. There are no exceptions. You can see that if you get the code, and I want you thinking about it. Okay, notes are where you can write things to yourself. You can write things to me. You can just write things about the program that's important. Sometimes the program does something weird, or it's got something unusual, and you put that in the notes. Okay, so there's main. All right, now the functions module is going to be very similar. So I'll go over it very quickly. Functions.h. All right, so I should also go back and mention we're going to cover C++ and Python. So this is for both I teach classes in Python, teach classes in C++. So if you're in the Python class, you should still be listening to this, because I'm saying a lot of things that apply to you too. It's just that your comment is going to be different. So when we get to the Python stuff, you'll see that. Okay. Again, I went to the functions.h, and what do we have? Just the thing at the top, the file comment header at the top. Don't really need anything else. Okay. So very simple, file comment header at the top. Okay. But let's look at the function CBP file. This one has functions in it. It has actual actual functions. Okay, so we have the comment block at the top, again, always every file, but now for every single function, you have a function comment, all right? A function comment block. There's one for this function, there's one for this function. Okay, there's only two functions, that's both of them, all right? And again, notice that it's listing everything. It's got a description. It says what the parameters are. In this case, there are parameters. We have these two parameters down here, right? So we list them. And we do it exactly in this fashion. Again, this is done so that automated documenting software can pick this up and parse this and create documentation automatically. So it's not just a random like format here. This is done for a reason, okay? Now, there's no exceptions in this function, so exceptions are none. It does have a return, and it explains the return. And you'll notice the way that these things are set up is it says there's a parameter, it names the parameter, okay? And now you don't need to say what type it is because the type is here. The type is automatically in the function itself. And then it gives a small description, okay? Same thing with return. The return, it says what the return is, and it gives a description of what's going on. All right. Same thing here for this one. So description, parameter one, parameter two, exception, return, and note. So in this case, on this one, the return is void. In this one, the return was an integer of some kind. All right. So that's the functions. Now, so we did main, and we did functions and functions, which are pretty much the same because these are all procedural programming style modules. Now let's look at a class. Okay, so this is going to be a little bit different. So in a class file, and this is where most students screw up. Okay, so most people screw this one up. Again, function comment block at the top, every single file. But now we have a different set of requirements for this kind of header file because it has a class in it. So you have very similar to function comments, or very similar to even to file comment blocks. Above the class, you put a comment block that's for the class. It describes the class, okay? And then maybe it says something special about it, right? Like this one says it's representing a square with a configurable side length because it's a class that defines what a square object would be in memory, what it would look like in programmatically, okay? And then it gives you a little extra piece of information here for something that might be a little unusual or different, or maybe something another programmer would read and find useful to know. And in this case, what it's talking about is the area is not an attribute; it's calculated on the fly. So it's just other information that you may not be immediately aware of when you just look at the header file itself. All right. So now here we have these are required. I'm going to stress this. This is what most students mess up. You have to put blocks that say, this is my constructor destructor. This is my getters and accessors block. This is my setters and mutators block. This is my printing methods. Now notice in printing methods, it says none. Even though, again, just like the parameters and the returns and the other things, even though there are no printing methods, I still want you to write the comment block and then say there aren't any. Okay. Again, this is that you wouldn't do that in professional code, right? You wouldn't go out of your way to say it's not here. Okay. But I'm doing this for the purpose of getting you used to thinking about this fact and where things belong. All right. So I want you to still write printing methods, even if there are none, or whatever. There might not be setters, there might not be getters. I don't know, whatever. It could be whatever, but it doesn't matter. You still have to put the block in, and you still have to say if there's something there or there's not something there. Okay. Same thing down here. So in private, we have methods and attributes. In this case, there is an attribute, okay, but in methods, there aren't any, so we say none. Now, again, most students screw that up because they stop thinking about something that isn't there, okay, and that's what I want you to not do, because being a good engineer is about knowing what shouldn't be in something as much as it is about knowing what should be in something, okay, so we're going to teach you to think about that, okay, and the other thing that students screw up a lot is this, here it just says methods. Well, all of these are methods, right? Like all of these are methods, and whatever I would write here would also be a method. So why do I call it methods here, and why do I specify what kind of methods up here? And the reason for that is if it's private, okay, we don't need to say getters and accessors, setters, and mutators because they're not publicly accessible. We don't need to define it like, yes, everything's a method up here, but because it's accessible to the outside world, we want to break it up by what kind of thing does the outside world get access to, okay? The outside world can use a getter, it can use a setter, it can use a printing method. But once you're inside and something's private, okay, then we just go like, well, they're all helper methods. There's only one kind of private method, really. It's a helper method, right? So it's not there are no setters and mutators or getters or accessors down here. So up here we break up by kind of method, and down here we just break up by methods and attributes. Okay, because like up here, there is nothing else but methods. There are no attributes up here. Down here, there could be attributes or methods, and all methods are one kind, which are our helper methods. All right, so that's your header file. And in the implementation file, right, the actual code, it's exactly the same as all the other functions. These are methods, right, because they're inside of a class, but it's just the same thing. Functions and methods are the same thing. So you just have the same kind of, exactly the same kind of function block at the top of everything, right? So even when things don't exist, you put them there. For example, this is a great example of not existing at all, right? It's a destructor. It has no code in it. It doesn't do anything, at least from the programmer's perspective. It doesn't do anything, right? There's no parameters, no exceptions, no returns, no notes. Okay, it destroys the square, but like it doesn't even do anything when it does that. At least from the programmer's perspective, like it actually does behind the scenes. But from the programmer's perspective, there's nothing here. You still put it here. You put it here to demonstrate you understand this thing exists. It could exist. It could have things in it, and you're thinking about it. That's why you do it in class. Okay. But otherwise, all of this is exactly the same. So you study this, study it very carefully. Make sure you go over every single example, and your code has to conform to it exactly. You can't miss one. You can't screw one up. You can't decide something else goes there. You can't decide something should be replacing it or switch them around or anything like that. Okay. Don't add things. Don't subtract things. Just do exactly what it says. All right. So let's go to the Python one. So now I've explained most of the concepts with the C code. I'll just do Python very quickly because it's going to be even simpler, and I've already explained most of the things. So if we look at Python main, now Python doesn't have header files, so we don't have to worry about that at all. So just forget about header files. You don't need to worry about it. And Python has docstrings. So what we're going to do in Python is we're going to use the triple quotes to make docstrings. There's going to be a docstring for the file comment header, same rule, exactly the same procedure. Everything I said about it in the C code applies here. You're just going to use different symbols, right? There are comments in the C code, there are docstrings in the Python code. Same thing goes inside though, exactly the same thing. Same thing with your functions, okay? You have a function comment block. Now the difference in this case for Python is going to be it's inside, okay, instead of above. If you notice, remember back to the C code, it was above the function because that's what the doxygen process and procedures say to do. But in the Python specifications, it should go inside. Okay, it's a docstring because you can actually call this thing, like you can actually call it and check it programmatically, right? So it goes inside the function because it's actually part of something you can call programmatically. All right, same rules. You put a description and you list the parameters, the exceptions. In this case, we call them raises, the returns, and you put a note. If it's none, you list them all and you still put none. Okay, so simple, right? Very straightforward. Let's go look at functions. So in the functions file, exactly the same thing. You put a docstring at the top. It's got your name, the assignment, and the purpose of this particular file. Remember, the purpose is a file purpose, right? What's the file doing? Okay, not the application. Same. Now we have functions here, right? So again, docstring goes inside. Now this time, right, we have more stuff going on here, right? So this time we have two parameters being passed in. And we list them: parameter square one, parameter square two. Does it raise something? Yeah, this time it does raise something. It could possibly raise a type error if either argument is not a square, and it has a return value: 0 if the squares are equal, 1 if first square is larger, or 2 if second square. Again, this is all part of specifications that help make documentation. And in this case, it's even more important because this is programmatically accessible, which means you can write code that will access the docstring from inside the application. So it's even more important that you get it right. Okay. Same thing here. This one's basically the same thing. Okay. So that's for functions. And now we'll look at a class file. All right. So same thing at the top. You should notice a pattern now. There's always one at the top. Okay. Always follows the same rules. And now the class has, just like the C code did, it has a general class docstring at the top. Okay, you just describe what's going on here. All right, and then we have the methods. Same thing, same rules, except it's a docstring now. So you put it inside, and you do the exact same thing that you saw with the C code. You put a description, you put parameter, raises, return, and note. It's always the same for it: parameter, raises, return, and note. Okay. And you just list everything that way. And if it's none, you still list it. So again, functions and methods are no different. Okay, same thing in C, same thing in Python. All right, so each one of these gets its own docstring. Okay, don't add anything, don't subtract anything, don't change anything, don't reword anything. Just do it all the way you see it. Okay, let's go back to here. We're going to wrap this up. So now these bullet points, I'm not going to cover them because they'll make sense. So if you read these bullet points, I covered all of them. Okay, but read through them anyways, just to reinforce what we talked about. And that's pretty much it for commenting. I'll just come down to here to wrap this up. General commenting standards and debug statements. Do not leave any of the following in your code. Okay, this is a habit you have to get into for professional code. You don't leave debugging statements in code. If you don't know what debugging statements are, they are statements that you write as a programmer to help you program. They don't belong in the finished application. They might be print statements or comparisons or tests or something that you need to get information out as you program. Remove them when you're done. We don't leave debug statements in. We don't leave commented code out. And these are kind of related because what a lot of people like to, especially students or beginning programmers, what they like to do is they put debug statements in, but then before they turn in the assignment, they comment them out. Well, you're halfway there, right? Like it's good that you thought about commenting them out, but you have to delete them. So we don't leave debug statements at all. We don't comment them out. We leave them. We get rid of them completely. And any other commented out code, we also get rid of that. If it's there are some exceptions. I'll explain one in a minute. But if you commented something out because like you were reworking it or you did something else and you did your code another way, go back and get rid of the commented out code. All right. Now there's an exception for when you leave that in. So every once in a while, I've done this. I'll give you an example of something I've done that's acceptable in professional code. I was working on some Python code, and there was a way to do it that was considered Pythonic, meaning the Python standard way of doing it, and I couldn't get it to work. And I tried everything in the world, and I sat there for 2 hours, and I couldn't get it to work in the Pythonic fashion, but I could get it to work very well in the traditional like C-style fashion. But C-style code is kind of discouraged in Python code, right? But I couldn't get the Pythonic one to work. And then what I eventually found out was it wasn't me. Okay, I found out that it was kind of a quirk of one of the libraries that I needed to use, and it wasn't a bug, but it was just the way it works. Just didn't allow the total Pythonic structure to function properly. Okay, so not my fault. It wasn't going to work no matter what I did. So there's an example where I left the Pythonic code in there, commented it out, and put a comment on it and said, this is the Pythonic version. It doesn't work because it generates this warning. And it generates the warning because of something inherent to the library. But I'm leaving it here in case in the future someone sees this code and that library is fixed or changed or whatever, and this might work. Okay? But in the meantime, here's the C-style code. So why would I do that, right? I did it for two reasons. One, I did it because I want anyone reading the code. It's kind of an egotistical reason. It's a pride reason. I left that code in there with a commented out because I wanted anyone who saw it to realize that I, as the author, knew better than to do C-style code there. Like it wasn't that I was being dumb or I wasn't knowing what I was doing. It was that I couldn't do what I wanted to do, and I wanted to leave a note behind saying so. So that's a kind of a prideful reason. The other reason I left it in there is it's probably useful in the future. Within a year or two, someone else, enough people are going to complain about it, and they're going to fix that library, and they're going to change it, and then that code will become valid, and somebody will come along and fix it. Okay, so there's an example of where you would leave commented code in there professionally, but that's not going to come up in school. Okay, it's not going to come up in academics, so just don't do it. And it points out that see how specific and how complex that reason was. That's your standard. If you've got a reason that's that complex, then you leave commented code in. Otherwise, you don't. Okay. Do not put trivial comments in your code. Okay. You don't need to write next to a print statement. You write print hello world. You don't need to write next to it printing hello world. Yes, we can read it. We know. Okay. So we don't comment every line. You don't comment things that are easy to understand. You don't comment like, price times tax equals, taxes, and then next to that, right, like calculating the taxes. Yes, we know, we can read it. In fact, if you have to write trivial comments, it probably means you're coding incorrectly because you're supposed to write your code so that it reads and you can understand it. So if you have to write a code on every line to explain your code, that means your code is probably bad, or it means you're probably just over commenting. Okay, so we don't comment every line. We don't write trivial comments. The rule is you only comment when you have to, when it's necessary. Okay. And that leads to the next rule, which is don't make excessive comments, minimal comments. In fact, you should be striving for as little commenting as possible, except for the required comments for documenting purposes, because your code is supposed to be self-documenting. And what that means is it's supposed to read so well, it doesn't need explaining. Your goal is to write code that doesn't need explaining. Okay, it doesn't need comments. Comments are there for what you saw, like things like this. Like this, these aren't comments explaining the code. These are technical details. Okay, that's what comments should be. If you got to come in here and write, next to this line, go, setting the attribute length to the default length. Okay, like we can read that. It says it right there. Okay, so you shouldn't comment that. Now, I'll give you one example of where somebody may tell you to do that, to do trivial comments and excessive comments. Some people use it as a teaching technique, okay, and that's valid. That's a different thing. I'm talking about professional standards, okay, and I'm talking about my teaching techniques. Other people are going to have different teaching techniques, and what some instructors do, and this is valid, especially in Programming 1, what they'll do is they'll tell you comment every single line, okay. That's not because that's what we do professionally. That's because they're using it as a teaching technique because they want to make you think about each line as you write it. Okay, that's strictly a teaching technique. We don't do it professionally, and I don't do it in my courses. Okay, I have other ways to get you to learn stuff and other techniques. Okay, all right. So commenting in addition to the required standards is allowed. So like I told you, don't change anything about the comments that I showed you. That's true. Don't change anything, but you might need to add some things without messing the standard up, okay? If you want to explain something that's not obvious, okay, put a comment in. If you want to explain a non-standard approach, like think about my example where I did C-style code in a Python application. I explained that with comments because it's a non-standard approach, and I had to explain why I was doing something like that. Okay, that's a good example of that. Or you might want to put a comment in for grading purposes. We're in an academic environment. You're talking to me when you submit your code. So like you might want to put a note in something, example of like maybe there's a known bug. Like you have a bug in there, you couldn't fix it. It was 11:58 on a Sunday. You had 1 more minute to turn it in, and you shouldn't wait the last minute. That's kind of your fault. But let's just suppose that's the situation. You might want to put a comment in to say like, yes, I know this is here. I was trying to fix it, but I didn't get it done. That will help your grades because if I find a bug and there's no comment next to it, what that tells me is you didn't catch it. Okay, you didn't know it was there. You didn't know you did something that wasn't going to work. And so that's worse to me, right? As opposed to you knew it was there, you tried to fix it, you wrote a comment that said you couldn't fix it, and at least you have some understanding of it. Like you'll get a better grade that way because I know you're further along in the academic process than the simple case where you just missed it. Okay. All right. That's it for commenting. So hopefully that helps and it gets you on the right track.